Hey everyone. Today I'll be doing the physics quiz for my time, at least tomorrow. I'm sorry for not putting it earlier. I had things to do. Now obviously it's not an excuse, but whatever. يلا, we'll start. The nuclear energy, where a heavy nucleus splits into two lighter nuclei upon bombardment by a neutron, is called fission. Now, what fission and fusion are? Fusion. Let me just go to the ebooks. Actually, I think it explains it here. Okay, this is fission. Let me go open the open board. The fission is when a large nuclei, splits into two smaller nuclei. So it would be like, let's say this helium, for example. This is probably inaccurate, but whatever. Helium would split into hydrogen and let's just say another hydrogen or something. I don't know. Uh, Now this is fission. A large nuclei, because this has the weight of 4 and hydrogen has 1, the atomic mass. As you can see, it's splitting into smaller nuclei. That's what fission is. Now fusion is the opposite of fission. Fusion is when two, let's just call them X so I don't like give out wrong facts. Smaller nuclei X make join together to form larger nuclei Y, for example. This is what fission. This is what fusion is, and this is what fission is. Okay. The nuclear reaction where a heavy nucleus splits into two larger nuclei upon bombardment by a neutron is called fission. Okay. Now, which of the following are disadvantages of nuclear energy? Select all that apply. In case of failure of protective covering, radiation can seep through the environment. Okay, obviously. And the half-life of a nuclear waste is very long. Uranium, I believe, lasts something times 10 to the power of 8 years. So it lasts really long. It goes up to 10 to the power of 15. Anyways, uh, anything else here? Now, you'll see in the next question why these two are wrong. Now, obviously, you just need to know one of these are wrong, and we know this one's wrong because nuclear plants don't really need that much fuel. Not a large amount of fuel, not like coal plants or something. Because coal plants, they need a large amount of fuel. Relative to coal plants, nuclear plants do not need that much fuel. Now, these two. Nuclear plants significantly contribute to global warming. They don't, because they're not releasing emissions. They're not emitting anything. Now, here, the same reason for this. Nuclear plants pollute the environment with greenhouse gases. They don't release gases that much. So these two, if one is wrong, the other one has to be wrong. And if one's right, the other one has to be right. Because, greenhouse gases pollute and they also contribute to global warming because they trap in the heat. No. Which of the following are advantages of nuclear energy? Okay. Psychological bias against nuclear energy, that's not an advantage. Can be built anywhere, including city limits. Now, this is technically an advantage, but it's not really a correct advantage because you can't really just build a nuclear power plant in the middle of a city. Uh, Power, because what if something goes wrong and then your whole city is gone? Fire, booms, what? God, whatever. Point is, you can't build anywhere. You need to build on like the suburbs or somewhere where there isn't anyone nearby living. Does not contribute to the greenhouse effect. That's correct. Power plant does require protective material. This is wrong because it says does not, and runs on a smaller amount of fuel compared to coal plants. Yes, that is what I explained in the last question. Okay. The internal energy of a system can be thought of the sum of the random kinetic energy, the chemical potential energy, and the intermolecular potential energy. Internal energy, yeah, basically what they said here. You just, if they ask you, they gave you the kinetic energy, they gave you the potential, the chemical potential energy, and the intermolecular. Add them up, and you find your internal energy of a system. But they won't give you. But just memorize them. This is pure memorization. Random, chemical, and intermolecular. Okay, question 5. Depending on the context, heat energy can refer to a random thermal energy, internal energy, or radiant energy. Now, this is what they said. Like if I go, they'll accept it in any order. Like for example, here I said thermal and I said radiant before internal. They'll accept it obviously. But just memorize the thermal, internal, and radiant, and you should get. They should also, I believe, accept light. Let me just check. Yes, they do accept light, so you can write light instead of radiant because they're basically the same thing. Which of the following are the uses of radioactivity? Measuring distances, that's wrong. Tracing the paths of reactants and biochemical reactions, that's true. Again, this is memorization. Determining the age of samples by their radioactive activity. Yeah, this is what we call carbon dating. And sterilizing food products. Now, radiation has nothing to do with brightness of stars or measuring distances because that doesn't really make sense. Now, as the current flows in an electric circuit, a battery provides energy to the circuit. Okay. This question is common sense. Energy is obviously transferred from the battery to the circuit and not from the circuit to the battery or anywhere else. Um, so, fairly straightforward question. Okay. This one's easy. Just need to have common sense. Night vision is infrared, obviously. A food heater uses microwaves to heat up the food. A medical imaging, obviously they're not going to use gamma rays or any other ways, X-rays. And broadcasting tower to give like radio stations or whatever the distributions. To like broadcast, they use the radio waves. Now, which of the following objects contain chemical potential energy? Now, once you see potential energy, it means it's not moving. So this is gone straight away. This is gone. This is gone because it says motion and this says moving. This would be nuclear, I believe. This wouldn't be chemical. So you just obviously the other two things. Now you should know from science, grade 6 or grade 7, food has chemical energy, and fossil fuels. Common sense. I don't really need to explain it. There isn't an explanation to fossil fuels, anyways. Like you should know this. Detecting the leakage on the walls of a pipeline can be done by radioactive tracing, which is an addition to what we said to here, where they said you can trace here, tracing the paths of reactants of biochemical reactions. It's similar, but it's just a different application. Okay, measuring the quantity of carbon 14 left in a bone is important in determining its age. Again, this is carbon dating. Radioactive dating, like what we said in the other question again. Okay. An important factor that must be taken into consideration when safely burying nuclear waste is the half-life, because the nuclear half-life of a nuclear material, not the half-life of a nuclear material, sorry, lasts a really long time. So I need to take into consideration where to bury it so it won't be touched, and how long will it be there. So then it could like stop being, well, its radioactive activity can half. Okay, underline the term that best describes the ability to cause the change. This is energy. This was like the first sentence in chapter 8. So you guys should know this. To be fair, anything else in these options are dumb. So now here, you need to know something called the quality factor. The quality factor, this is how you know the dose's strengths. This was like very briefly explained for me in my class. I don't know about you guys, but it's in the book. And I looked at it here because I was lost, but then I just read over the book. I found it here, so I highlighted it. Okay. Well, I didn't highlight it. I searched for it, to be fair. Now, here you need to know the weighing factor or the quality factor. They're the same thing. Now, gamma rays and X rays have a weighing factor of 1, and the beta particles have a weighing factor of 1. Neutrons have to 5 and 20 depending on the speed. They'll give you the speed. They will also. They won't tell you anything else, so you don't need anything else, anyways. Alpha particles have the weighing factor of 20. So alpha particles have the biggest or the greatest quality factor. Now, what you do, you multiply the rads that they gave you by their quality factor. You memorize it. Quality factors are easy because everything is 1 and everything is 1 except alpha particles. Now they won't give you neutrons because they didn't specify how to determine how much its quality factor is or weighing factor. So ignore the neutrons for now. If they do, they'll probably tell you how much. Now, what you do now? So for example, we'll test the alpha particle. Alpha particle radiations have a quality factor of 20. So it's 20 times 2. So our dose would be 40. Obviously do this on a calculator. Ignore this. This is the worst 4 I've ever seen in my life. Now 30 rads of beta radiation. 30. This would be 30 times 1. So this would be 30. Okay. So far our alpha particle is the greatest and our beta particle is the second greatest. Now 50 rads of gamma radiation. So 50 times 1 is 50. So I'll just write 50 times 1 equals to 50. And zero point 0.5 rads of X-ray. So zero point 0.5 times 1, which is 0.5. Okay. So we rank. So our two rads as alpha. So this would be, so far we have the gamma that's the greatest. This is gamma. Alpha second greatest. Beta third greatest in this case. And the X-ray last. This is how you would solve this question. It's easy, but some people didn't read the book and this is what they get. Okay, last question. The type of radiation that's most suited for the setup, let me just read the given. The diagram below shows an automatic setup used to check where the level of yogurt in a cup is above a certain level. Okay. The type of radiation that's most likely suited for this cup is beta radiation. A radioactive sample of this source should have a long half-life to last longer. Okay. Um, no, this probably just memorization, but I'll check the next. I'll check the book because I didn't see a reading for this. بصراحة I have no idea why they did this. I'll check, then I'll leave it in the comments if I do find an answer. If not, just memorize it because I probably bring it the same. Okay. Anything other than that, I explained everything that does need to be explained and everything that needs to be memorized. I said this needed to be memorized. Okay, this is it for the physics video. Bye guys, have a nice weekend. يلا see you next week.